welcome you all on the third day of the one-week online certificate course on computational mathematical software, Mathematica Maxima and R, organized by the Department of Mathematics, Atma Ram Sanatan Dharm College, University of Delhi. We are delighted to have today with us Professor Sandeep Banerjee, who is professor at Indian Institute of Technology, Roorkee. Professor Banerjee did his graduation from St. Xavier's College, University of Calcutta. He did his post-graduation and PhD in applied mathematics from University of Calcutta. Professor Banerjee was postdoctoral fellow at University of Helsinki, Finland. He is a recipient of several prestigious awards, grants, and scholarships. To name a few, National Scholarship in the Bachelor of Sciences in 1991, Indo-US Fellowship in 2009. His contributions in the field has been also felicitated by Indo-US Technology Forum. Professor Banerjee has to his credit a long and rich list of publications. His 4 papers are published in national and 44 papers in international journals. He is author of 4 books. He has delivered 27 international and 27 national invited talks and lectures in the capacity of resource person. Professor Banerjee has been course developer in National Program on Technology, Enhanced Learning, and in an MHRD project, EPG Pathshala. Today, Professor Banerjee shall be introducing to us the niceties of Mathematica, how to solve basic arithmetic operations, 2D and 3D graphics, numerical methods, and its applications using Mathematica and much more. We are delighted to have you, sir.
Thank you, Priti. So to the participants during, mostly it is the hand-on session. So if you have any difficulty, you just type in the chat box and then I will just revert back in the page. So let me share the screen. Okay. Okay, I think you can share, you can see the screen. So this software, Mathematica, it is mostly used for research purpose, but these days you can use for classroom teaching also, and also to solve your own problems and so on. It's very handy in that. So I assume that you have no idea what Mathematica it is. I start from the very, very basic. For example, the notations. Say if you want to add 2 numbers, it is just plus, and your outcome will be you have to press shift and enter. By shift and enter means you have to keep pressing the shift and then press enter, and you get the the values. Similarly, subtraction. For multiplication, if you just write side by side, it will give the multiplication. Otherwise, you could have used this one also. No, this gives something else. So you just give a gap and it will take. Oh, yeah, it's 54. Yeah. Oh, okay. So if it is star, so let's make it 56. It will give the same. So either you give a gap or you put a star. That is for multiplication. And for division, it is just front slash and it will give the number. So if you write 26 by 5, it's going to give back 26 by 5. If you want a numerical value, you have to put 26 dot by 5, and it will give you the numerical value. Or there is another way of writing. You just write n for numerical value, and you get the 5.2. Oh, okay. Is the voice clear now? Somebody?
Yes, sir.
Yeah, okay. Somebody can write in the, okay, cannot download. Okay, fine. Okay, so if you want some power, it is say 6, it's 6, it is hat. So this will give you 36. So these are just the basic operations. And now some inbuilt function, say pi. So pi. Okay. Is the digits small? I can increase the size, say, by this much. This looks better.
Yes, sir.
Okay. If you want say numerical value of pi, all you have to do is put a n. You put pi, and it's going to give you some value. If you want this, say somebody wants pi to 50 places, all you have to give is pi and write whatever number you want, and it's going to give you the value up to 50 places of decimal. Similarly, you have exponential, say -7. So this is e to the power 7. If I make it plus, it is e to the power 7. If you want the numerical value of exponential 7, it will give you the value. So whenever you need a numerical value, all you have to do is type a capital N in front of the function. Then you have, say, log 5. If you want a numerical value, it will give you the numerical value. Now, this is base E. If you want any other base, you have to write that base in the beginning. So log 5 to the base 10, and the value is something different. This is to the base E. Okay. If you want absolute value, which is your modulus function, and say okay, so this I is a complex I. You write it as capital, -6 plus 5y divided by 2 minus 3y. If I want the absolute value of that, so it gives absolute value. if I put a dot here, it's going to give me the numerical value. So let's write it like this, without dot, without. So another way of getting the numerical, so if I write n here, it surely will give me the numerical value. But then another way is, I just put a dot anywhere. It can be here, it can be here also. And you get the numerical value. As you can see, both are same. Okay, anything? Yeah. So mostly cannot start the software. Anyway, basically you're supposed to install it before. The trial version is something like they have to download and then they have to start, is it? Or it's just works when they click the link? Anil? Okay. Okay, it's an online program. Okay, fine. So those who are working and I mean, those who can do it, it's fine. Those who cannot, you take the recording later. Okay. So those who are doing what I am doing, if you face any difficulty, you write in the chat box. I am constantly watching the chat box. Yeah. Okay, we use n for the numerical value actually. So if you don't want to use n, so this is the absolute value which you get. It's you mean the modulus of a complex number. So it gives this. If you are happy with it, it is fine. If you want a numerical value, you write a capital N here. There are two ways of writing it. One, you put a capital N, then put a square bracket, or you just put a dot anywhere in the number. I mean 6 point or 5 point or 2 point or 3 point, and it will give you the same value. Yeah, I think this is better. You keep on writing on the chat box and I see the chat box and answer your queries. That is quite interacting. Good. Okay. Okay, let's move on. So next we write, say, cos function. Cos pi by 6. And if you want, again, the numerical value, either you put an n here, or you just put a dot, and both will give the same value. So that is totally up to you. For sine inverse, we use arc sine, and arc sine of half, which is pi by 6. So I took a known value, which is because we know sine 30 is half. So half will be sine inverse 30. So arc sine is basically sine inverse. If you want it in numerical, you just give a dot and you get this. But in this case, I prefer a non-dot one so that it is clear. Okay. Okay. Then let's move to simplify. So simplify, so in mathematical, the commands are something which is very, very user friendly. How to do online? Generally, I guess you have been sent a link. You have to click that link and maybe you have to register, something like that. Okay, simplify, say if I just write sine square x plus cos square x. So the syntax has to be correct. I think this syntax is wrong, and you will get something like this. So it is not reading it. So what you have to do is, this is your sine x, and this is your cos x. So now you can see it is sine x and cos x. So I need a square. So sine x square, cos x square. So it will be read as sine square x plus cos square x, and we all know the answer. Now it's working. So it is given to be 1. So syntax is very important. So this is with the simplify. Keep the first word. No, the first word capital is, these are the inbuilt command kind of thing. So if I keep it small, it will not work. So Mathematica has a inbuilt syntax of its own. So that's why this is capital. Okay. So what you are just seeing is, it is very handy right now for classroom teaching or classroom simplification. Like for example, say trigonometry, 3 expand. And I need suddenly the formula of cos 3x. So the command is 3 expand, and it is supposed to give me the formula for cos 3x. So cos cube x minus 3 cos x sine square x. So that is how you will read it. Okay. Then you say want to quickly simplify trig reduce. Say sine 4x cos 10x. And I want to know what is the, so immediately it will give me sine C plus sine D kind of thing. Okay. Next, let me show you. Any questions? No. Okay, so square root, SQRT. Square root of 16 square root of 17, and obviously I need a numerical one, so I just put a dot and it will give the numerical value. Okay, there is another command. Yeah, I will come to maxima, minima thing. Okay, apart. So this will write it into a sum or difference of two fractions. So we need this in our partial fraction thing. So apart is the one which will work. Let me check one more time. Okay, so here is the catch. The simplify, you are using a small s. There is some message with answer after using simplify command, like aborted. It should not be. So if I write simplify, just check whether you have written this as capital or small. If you write small, it will just revert back this. If you are getting the answer, I think then it is fine. No problem. There should not be any problem. Okay, so this apart thing, if you notice here, it is 1 by something. Now, when you write 1 by 2x plus 1 into 3x minus 7, I assume that this whole thing is in the denominator, but it is not happening like that. So it is taking 1 by 2x plus 1 multiplied by 3x minus 7, and then it is giving this. But to keep the whole thing in the denominator, I have to close them again with a bracket. So that's why this second bracket has come from here to here. So now it reads as 1 by the whole product thing is in the denominator. So as you can see, this answer and this answer is different. So we need them in partial fractions. So this software is quite handy when you are, solving problems of your own while you are setting a question paper. You just, in the click of a button, you can just get the answer very easily. Okay. Next, just check this one. Say fx. So now I'm defining a function. Fx equal to x cubed. And I want to find f2, but it is not giving me the answer because the syntax is, you have to remember. So generally this is our trend. This is how we write fx equal to x cubed. So you have to give a underscore here. Fx underscore equal to x cubed. Now it has read as a function, and this x underscore is a variable. So if I now write f2, it is reading as I substitute 2 here, and what is the outcome I will get, which is obviously 8, as you can see here. Okay, any questions? No. Okay, there is one thing I'd like to show. So sometimes we want to see the expression in the actual mathematical form we write, like this one. Come in. क्लास चल रहा है एक मिनट. क्या है? Okay, sorry. Okay, so if you want, this is fine, but sometimes people want to see them in the mathematical form that we are used to write, that we generally write. So for that, use these palettes. If you click a palette here, you come to others, and you come to basic math input. So it is something like Word, typing in Word, MS Word. So once again, click the palette, go to others, and basic math input. The moment you click, this kind of box will open. This. Now what I'm going to do is I'm going to type this. So this is a fraction. I put a fraction, and then it is x minus 1 whole square. Okay, so I put x minus 1, and this is for the square, x minus 1 whole square, and here it is x square minus 1. So now this is the kind of, representation we are mostly familiar with. So if you write simplify here, this is exactly what you got here. Palette option is not there. Okay, maybe a different version or. Okay, so then we leave the palette thing. Okay, we now move to the plot. Okay, let's leave the, so let's see some graphics now. Plot. So simple thing, sin x. And you have to give a range, x say 0 to 6 pi. Sorry. And this standard graph, which we all know. I make this cos x. Okay. Now I want to join these two. So I name it as P1. I name this as P2. I run one more time. Run one more time. And if I want the plot of sin x and cos x in the same frame, I just type show P1, P2. And you see both the graphs in the same frame. Okay, let me. So if you need any help, just go to this help and type the most simple word that comes to your mind regarding to what your search is. So I give plot itself. and I press enter. So it gives now plot. So generally we don't see the syntax first. We straight away go to the example. So this is the example which I was just showing. If you want this option, so option is the where various what we say attributes can be attached. For example, what color I want the graph, what will be the axis, what is the axis level. Axis level is the x-axis and the y-axis. So let's do one by one. Save this one. So axis level. So if I put it here, axis level x sine x. So as you can see here, x has come along the x-axis, along y-axis, it is sine x. So that is what the work of axis level. Then say, okay, plot somewhere. Say color function. So these are all a inbuilt command, and it will come through practice. So if I want a color function, so it will just change the color. It is dark rainbow, and you got something like this. Let's see if we change to more simpler one. No. Dark rainbow. Yeah. So now if you want, you have two different things. Okay. So now you know which one is which, which one is sine x, which one is cos x. But there is another expression. Let me just check. It's called plot labels. So if you give these expressions, so it will give that this line is actually the sine x. Okay, there is another way of combining the graphs. You can write like this: plot sine x cos x. And I put them in a curly bracket. And x is 0 to 6 pi. I'm doing the same thing. And I'm writing plot labels expressions instead of axis level. Let's see what it gives. So this is what I meant by expressions means wherever it is, it ends, it gives this is my sine x and this is my cos x, and they give you in this same plot. Let's see, any questions? No command is working. Okay, so work the command, you have to press shift and then enter. So by that I mean you keep pressing the shift and then press enter, and then it is supposed to work. For example, this one, this particular thing. So you have typed this whole thing, press the shift, and then keeping the shift pressed, you press enter, and it's supposed to give this. Is it working now, Rama Sandhu? Okay. So now is the interesting thing. Okay, it's working. Good. Okay. So often we like to see how your graph behaves. This is a very important command in Mathematica. So I am plotting sine x. Now I want to see how this graph behaves if I introduce a parameter. For example, I put a here, sine ax. Okay, please be careful here. There should be a gap between a and x. Means if you write like this, sine ax, you will get an error. Because Mathematica is reading this a and x as a single variable, whereas they are different. So you have to give a gap between a and x. So I put, say, a equal to 1.5 before plotting. I attribute the value a as 1.5, and then I want to. So this will be the graph when a is equal to 1.5. Now I want to see what will happen 1.6, 1.7, 1.8, and how the graph changes. For that, I first clear this value. So the command for this is clear, clear a. So clear a means this value of a is attributed 1.5. I now clear it. The moment I clear it, you can see that this has now again become blue. If I click this note, notice now, if I attribute the value a equal to 1.5, you see the color of a changes. And now here, if I do it, I get the same answer. Whereas if I now clear it, so a is not 1.5 now. And if I try to plot this, it will not give the graph. It should show an error because it will looking for this value a. As you can see, the graph is not plotted because it cannot get the value of a. Okay, I want to now vary a. So command for this is manipulate. manipulate this whole thing. And now I will put the value of A from class A, say from 0 to 3. Okay, now let's see what is happening. So now what you get is a bar A like this and a plus sign here. You click the plus sign, a movie has been generated actually. So if you click this, that movie will play. Now the first thing is you get a flat line. Why you get a flat line? Because it will start from A equal to 0. And if you put A equal to 0, you get sine 0 and the answer is 0. So that's why you get a flat line. Now if I start this playing, you can now see how your curve changes as the value of A is varying. I can slow it down. This is the faster, this is the slower. So I've slowed it down a little and you can see. Let's see, any questions? No. So those who are doing it on screen, I want you to find the value of sine AX plus cos BX, where you now vary the value of A and B. Give a try, just say take 1 minute. So I will copy this whole thing. So all I will do is I will just add plus cos bx, and I will give a gap between b and x. X is from 0 to pi. This axis level right now I'm deleting it. So A is from 0 to 3. B is from say 0 to 2. And it should work. Yeah. So now you get 2 bars. And as you can see that this has started from 1. Why this has started from 1? Because x is 0. If you put x equal to 0, this value is 0, this value is 1. So it has started with 1. Now you vary one of them. Make it a bit slower. So now I vary both of them. And this is what will happen. So I give a lag. Now at any point of time, if you want a particular value of A and B, and for a particular value of A and B, you need the graph. So all you have to do is you have to stop them. You put any value of A. So I want 1.56 and I need a value of B, which is say 0.2, so 0.98, and I press enter. So this is the graph which you will get at A equal to 1.56.98. Let's see, any questions? No. Yeah, any questions? Okay. Okay. Let's take plot 3D. So say z equal to x plus y square, something like that. Sine x plus y square. This is my plot, and I have to vary both x and y. So x from say -4 to +4, y from say -3 to +3. So it's some sort of symmetricity is there. So, and I get this. So the beauty of this one is I can rotate this one. So the moment you bring it, your cursor from here to here, you see this rotatory sign. You press the left key of your mouse and you rotate. And you bring to a position which you feel I change this function, say x square plus y square. So this is one. So if you want two functions, I have to just put them in a curly bracket. And the same thing with the negative sign. And say, let's make it symmetrical. 2 plus 2 minus 2 plus 2. Okay, query. No. Okay, let me just check with x, y, z. So here I've assumed that say z equal to this thing. Let me quickly check that. Okay, I think this should work. It is called region plot. Region plot 3D. Oops. No. This one command works only for inequality. Let me check. Yeah. Okay, so the command for the XYZ is contour plot. So it is only you have to search and get the right syntax. Contour plot 3. And when you put an equal to, make sure you put 2 equal to's. That is important, not single. So now it gives you for the equality. So if you want the inequality one, here you can rotate and you can check which is your good view, and so on. Okay. Yes, Alok, is it okay? Richa, what is your question? I didn't understand. Region plot is where the inequality will work. For contour plot 3D, you can get the whole graph in XYZ. Okay. So here also I apply the same thing. Say I want to introduce a parameter A. And I want to see how my curve will behave as the parameter A varies from 0 to 2. And I use manipulate. Close. So it should work. So as you can see, it works. And if I so as you can see, it is though it is giving this kind of figure, but when you stop it at certain point, it take few minutes and then actually it gives whatever you want, and then you can just see which one you want. And so when it is moving, it cannot give that static kind of figure that we are expecting. But when you just stop for a particular value, after a few seconds, it just gives the actual surface. Okay. Okay, so the difference between the plot 3D and contour plot 3D is just in the syntax. In the plot 3D, I have expressed this in the form sine of ax plus y square. I assume that z is a function of x and y. So if I can express z as a function of x and y, and I can straight away write it. So that is where plot 3D comes. But then somebody wants a function of x, y, z. there where the contour plot comes, because here you can see the whole equation of the surface. Let's see if it gives a, so that is the basic difference. See, I want a sphere. Just want to check whether it works. Okay, it works. Only thing is, I think I have to. Yeah. So I just have to increase the limit. So here it depends what value is here. Say 20, I make it 40. Yeah, 20 square, 400. So I make it 200 and it becomes bigger. So now it will become a sphere also. About 300 and it becomes bigger and bigger. Yeah, any questions? Okay, no. Okay, there is one more thing. Get it. Surface. Yes, we can plot vector valued function. Okay, I'm coming to that. I think what you meant is, let me check. So just confirm if you what you mean by vector valued function. Say for example, if I write a vector plot of say y comma minus x. So this is a vector in variables. And I give some range. So x from -3 to +3 and y from -3 to +3, say. Oops. Yeah, now it's okay. Is this what you meant by is this what you meant by vector valued function? That was from Amit. Okay. So some sort of parametric plot. You want a 3D. Okay, let me check. t squared t cube plus 3. Okay. Let me check. Say, okay, let me quickly check this one. I think just some syntax error. No, I think it is okay. It is 3D. Yeah. Yeah. So maybe if I make it less, yeah. Yeah, this looks better. So this is how you will get the vector. So you just put parametric plot 3D and t squared t cube 3 and put a range of t. Okay, fine. Let's see any queries. Okay. Okay, data without equation. Yes. So there is something called list plot. So this is how you will search when you don't know the actual command. So you go to help, go to Wolfram documentation, and say, I don't know this list plot. So I will obviously give plot first. And here's the plot thing has come. And under this plot, a lot of things will be there. So by looking at this, you see that there are some sort of points. And if you click that, so see the syntax, and then you go to the actual examples. I think the one which is, so you just write, say list plot should work. 1, 1, comma 2, 4, 3, 9. Nope. List plot, missing something. Let me check. A syntax. So syntax is very important. As you can see, I have given this one. It's not working. So I have to give two brackets actually. So this was fine. So all I have to give is two brackets here. And it will work. So little more if you want 4, 16, 5, 25, 6, 36, and a little more. If you want to join, joined, you just write true, and it will join them. Okay, so let's see two of them. So one is if you only want the plots, which is this. Another if you want them to be joined, which is this. Okay. Okay, any question more? Let me check. Okay. Okay, so difference between plot, contour plot, region plot. So by that, I assume that plot 3D. So when I writing plot 3D, you can see that there is no Z. So I'm assuming Z equal to as a function of X and Y. So that will, so if you can express Z as a function of X and Y, your plot 3D will work. Suppose you want a region plot, then it has to be an inequality. So it will determine certain region. Suppose if I write it as less than 0, so it gives something else. Previously it gave greater than 0. So you get less than 0 means this part is now deleted. And if you want a contour plot will where your 0 will work. So that is the basic difference. Okay, list plot bhi ho gaya. Okay, so use the command plot and draw a circle. Let's see, 1 minute. If you have any queries, keep typing. Okay. Anybody got it? Just type in the chat box. Okay, fine. It is joined true, JOINED. It's for joining the points in graph, yeah. Or there is something called line plot. Line plot will also join the points. Yes, sir. Any means by any means, if you construct a circle, that will do. Plot is one. Another is here. It's already there. Contour plot 3D gives the sphere. So if I want a circle, I will just use contour plot. I will remove z square and I will remove this one. So this should give me a circle and it gives. So there are multiple ways of plotting. So this is one of them. Okay, let's now move to matrices. Say, how will you type matrix? You write A equal to, say, 1, 2, minus 7, 5. And then again, put it in a curly bracket. So this is a matrix in Mathematica, but however, we don't like the look. So if you want the look that we are usually familiar with, you have to write matrix form. And I put A. So A, I already attribute whatever the values are. So it's a 2 cross 2 matrix, and I know that this is my matrix. If I want so if I want inverse, yes. So these are various, you can just use it for your, question paper setting, and you suddenly need to calculate. So this is the inverse A. And if you want them in matrix form, you just write B equal to this and matrix form B. Or you can straight away write here I think this should also work. So instead of B, I just write inverse A, and it gives the same answer. If you want to find the determinant of A, I think this is, so it's 19. If you want transpose, so all possible operation, and I want the matrix form. So it was 1, 2 minus 5 minus 7. Just give me a minute. Yeah. This one. So if I, sorry. Yeah, oh, okay. So the transpose is, this was 1, 2, minus 7, 5. So if I transpose it, rows are changed into columns, 1, minus 7, 2, 5. So 1, minus 7, 2, 5. Even if you want the eigenvalues, so it will give you straight away the eigenvalues of A. And if you want the eigenvalues and eigenvectors, I think the command is eigensystem, sorry. Eigensystem of A. Class আছে, একটু পরে। So this is your eigenvalues and this is your eigenvectors. Any questions? No. Okay. Okay, trace also it will calculate. I think TR is the trace. Yeah. So trace, I know sum of the diagonal elements, which is 6. Well. Okay, আমি একটু ক্লাসে আছি, পরে ফোন করছি। Okay, and then we have, okay, characteristic. Okay, one question. How to get matrix? That's okay, Richa. So what do you mean by how to get matrix? I mean, how to write the matrix? Okay, let me just quickly show you one more time. So any matrix, it is in this form. So this is 2 cross 2. If you want a 3 cross 3, I put a 1. So I put a 0 and I add another row. Say 3, 4, 6. And this is. So if you want in a matrix form, okay, so this I make it, say A already given, I make it double A. So I matrix from AA. Okay, is it okay, Richa? Okay, another way is, do you have the palette there in your software? Otherwise, this is the easy way. Or you can use palettes. Okay, then fine. No palettes, so I think this is the easy way. Yes, another was characteristic polynomial. Yeah. So if you want a characteristic polynomial also, then it will need x. So it gives the polynomial also. And if you put equal to 0, it's a characteristic equation. And you can solve it. Okay. Let me move to day 2. Let's see, any questions? Okay, no. Okay. Let me quickly do the derivations. So to find the derivative, it is just d, whatever function you want to put, say x to the power 4 minus x cubed plus 7. And you have to mention with respect to which variable. And it gives you the value. If you want a second derivative, it is only the syntax. So all you have to do is give a comma 2. So it's doing the second derivative. So the comma 2 will be x with respect to x 2 times. And we know the answer here. So 12x squared minus 6x. So this and so on. Okay. See questions. Minimal polynomial of a matrix. Let's check. Not everything can be done, but let's see. Yeah, so there is a command minimal polynomial, and you can just use it. Yeah. How to get PDF of this document? Let me check. File, save as. Yeah. So all you have to do is go to File, save as. Here it is save as type. Here is the PDF document. And the moment you save, it will save it. Okay. The same is with integration. Integration, oh, sorry. So it will be integrate, whatever may be the function, x square, and I have to put with respect to what, and it will give me the value. If I want to integrate within the limits, then I have to put the limit here, x square, x from 0 to 1, and my answer is 1/3. Okay. Let's see. So you this differentiate when sometimes you need the answer. So for example, if I take a complicated one, d of something like x plus 1 by x whole to the power x. And I want it to differentiate 2 times. So if you just want the answer, in a click of a button, you get the answer. If you want to simplify, put it in a square bracket, and it gives you a simplified form. Suppose I want this value at x equal to 1. I think the command is, that time you may give a simplify, you may not give a simplify, because really doesn't matter. So this is the value. I think that should be slash dot x tends to 1. Yeah. So this is the command. You are differentiating. Up to this much is the differentiation thing. And then I want what will be the value of the derivative at x equal to 1. So I just give slash front slash dot x tends to 1 and it gives me the value. Any questions? No. So the same thing is limit, say the known one, sine x by x, comma, limit x tends to 0. And the value is 1. Okay, so how you putting this tends to, it is something like you put the dash and you put greater than. It will automatically take tends to. Plot of complex valued function. Let's see. Okay, so there is something called complex list plot. I've not done it, but let's check. Says complex list plot. Okay, so it's an inbuilt function. Yeah. So you have something called complex list plot. Rest you can see. So it is an inbuilt. All you have to put is just the complex numbers Z1, Z2, and so on. There is another thing also you have to see this. Yeah. So there is absolute argument plot. There is complex plot 3D. So everything, the whatever available in real, it is also available in complex. So you can just explore that part. So let me check another thing. complex plot 3D. Yes, again, it is an inbuilt function. Yeah, so the examples are given. Complex plot 3D, just put the number and whatever the Z is. So you have to give the range and it will plot. Is it okay, Samanne? Anish? Yeah. So whatever you want mostly is covered by Mathematica. All you have to do is you have to just search. Most of them are inbuilt commands. But suppose you are not getting what you are looking, just Google it and you will see always there is a 3-minute, 4-minute video how to do that. You will always get it. It's a very popular software. So people explore a lot. Okay, this one is done. Now let's just explore numerical methods. Okay, so if you want to write something in Mathematica, which will not coming in this, commands, but something which you have to, some title or something, you have to put it in a star like this. So this is now deactivated. It will not work anything. So, but you can see this is now numerical methods. Okay. Say, okay, there is something. Why we put sin x in square bracket? So basically it is the, the syntax of Mathematica. If you put it in a normal bracket, it will just not work. It is their inbuilt program actually. So here it is just taking something. Okay, so it is taking sine multiplied by x divided by x. So x cancels and you are getting sine. But anyway, so it is their syntax. It has nothing to do with us. So every software has its own method of writing. Okay. So the first thing is the interpolation. So basically, Mathematica has their own way of doing it. So if you say that I want to find the interpolation, Lagrange's interpolation formula, then actually you have to type the Lagrange's interpolation formula. Otherwise, they have their method. So let me just show you. Yes, exactly. Any function, it is the trend that you put a square bracket. Correct. Any table, it should be in this curly bracket. And our usual bracket is the first bracket only. So if you need repeated bracket, you have to put repeated first brackets. Okay, so I've already opened that, an interpolation. So you have an interpolation, but the one which you want actually is interpolating function. Let me see. Okay, interpolating function. No. Let me check. Interpolating polynomial unit. Yes. In this one. So generally we are given the x and the y values and I want to find what is the polynomial. So inside they have some inbuilt formula. which they use. So this is easy for, for checking the results. And okay. Now, there are many ways. Another way is, suppose I want what will be the value of x of this polynomial at x equal to 1.1. Then the command is a percentage. This percentage will only come just after this result. Means percentage will take this particular output. So percentage, then as usual, front slash dot and say x tends to 1.1. So what it will do is this percentage will take this output and it will put the value x 1.1 and it should give me something. Yes. Let me quickly check. So if I put 0, it's supposed to give me 4. What happened? Sorry, 2. So as you see, if I make this as 1 and enter, it is still keeping it 2. So this percentage only work once on this output. So if you want x equal to 1, I will again run this. Now this is activated. Now this percentage will take this outcome and put the value x equal to 1 and give me the output, which is 6. Okay, questions? So which interpolation? Basically, I really don't know. So inbuilt, they have something. I think the safe side would be Lagrange's because it will work with, forward, backward, or say divided difference, Newton's divided difference. So that will work for all of them. So something which is inside. Then say this integration, I found something which I will show. Say integrate. These are generally, okay, let's take sine x squared, something complicated, and x from 0, 1. Okay. Just to make it n integrate. So this will give you the numerical value. Oops. Okay, so in integration, I find there are so many rules that you can use. The common one is this trapezoidal rule, Newton-Cotes rule, maybe Gauss method. So suppose you want to, or even Monte Carlo, these are the common things which we use in your BSc. So that time you have to just write like this, something like this method. And method, you just write, say trapezoidal or Monte Carlo. I think I have a trapezoidal, yeah. Okay. Yeah, so if I just copy this one, okay, let me take the same thing. Sine of x square 0 to 1 and I use trapezoidal. But if I just write integrate, I think it should work. No, it becomes red, so it will not work. So I have to give an integrate, and it will. So it worked. It's the same thing. Trapezoidal. Let's see if there is something Simpsons. I don't think so, but then find Simpson. I don't think it will work. It's not there. Simpson's rule is not there. Any questions? No. Okay. The last one. Let me show a bit kind of, say Newton-Raphson. Okay. So to find the root, either there is n solve, that is, it is numerically solving something. If you go for help, hello. हाँ तो 10 मिनट बाद आ जा, ठीक है, 5:30 तक क्लास है मेरा. Okay, sorry. N solve. Yeah, so N solve, it gives some solution, numerical solution. So this gives me a real root. If I don't write this one, it gives me all possible roots. Okay, so N solve is one of them. Another is find root. So advantage of find root is, so let's see what it gives. Here only you have to give the expression, and I have to give x, and I have to give an initial value. Say I put 0. Let's see what it gives. Okay. So as you can see, it gives some error, and also it gives some, command. So I put some 0. The only real root is 1.42367, and somewhere it becomes, non-convergent, couldn't find it. Let me move, because I know the root. Let me move towards the root. Still it doesn't give. No, I think then something wrong.
Root is a negative root.
Node. Correct. Sorry. Good. Yeah. Thank you. Yeah. It should work actually. Yeah. So sometimes if it happens something like this, you be sure that it is your fault somewhere, the typing or the syntax. So since it was deviated far away from the actual root, it couldn't give the root. So find root will be handy for you while you use your numerical method, where you need an initial value. And in solve is something where you get all the roots and you are sure of your answer. But means if you actually want to use this Mathematica for numerical methods, double equal for an equation. Yes. X equal to -1 here. Oh, that is because I can see from here the root is minus 1.42367. So already I have solved this equation. So that's why the initial condition is taken as -1. Okay. Yeah, so as I was saying, suppose let's in solve simple one, x square minus 2 equal to 0, comma x. Okay, so these are the two roots. If I use find root, x square minus 2. So if I give -1, it will give the negative. If I give +1, it should give the positive. Okay. Now, this is how it works, but if you actually want to do the actual method, say Newton-Raphson, so I will just quickly show. So you define this function. And you put a semicolon. Okay, so x comma 1 means that you're finding the root of this expression. X is the variable, taking the initial value 1. Okay, so if I don't put, okay, in this way it doesn't matter, but it means that it will not be reflected in the next line. So some value. So this 1.5 comes here. If I put this, it will not come. So that is how it works. So what I'm doing is I'm just writing the formula for Newton-Raphson. That is equal to xn x minus fxn divided by f dash xn. And say I put n from 0 to 5. Okay. I think this should work. Let me just check. Yeah. Okay, so what you're doing is this is just some sort of cross check and everything. So you have used, I have the equation x squared minus 2 equal to 0. I'm solving with respect to x. I got these two roots. Now you want to use any numerical method, say Newton-Raphson. So I use the find root also, and I see that if I put 1, I get this value. If I put -1, I will get this value. Now, here I just wrote the formula for Newton-Raphson. So this is the function. This is the initial value. This is the formula. So do is a do command which go on repeating. So it will put 0, it will calculate the value. It will put 1, it will calculate the value, and so on. So the formula is xn plus 1 equal to xn minus fxn divided by f dash xn. We all know that. You have to print n xn. There should be a gap. No. Anyway, so then this table form, I think we can remove this one. Yeah. So the table form is n xn. So this is your n, this is your xn. It starts from 1.5 and it gives you this value. So this is exactly what you are familiar with. Now, so that is exactly what I'm saying. If you want your answer in this form, you have to write a small code like this. So this will work for Newton-Raphson, then your fixed point iteration. So all you have to do is change here, whatever the formula is, and it will work. Let's see, any question? I really don't think there will be a difference, but so this is the plot of fx. So we know the root you get will be when it crosses the x-axis. So it crosses the x-axis somewhere here, and which is approximately 1.41421. Okay. So just let me quickly check. One question was raised. If I write this equal to, say, x squared plus 4, then will this give me the answer? So I really don't think it has any difference in this particular case. Okay, so if I write f, I just make it 5. So it gives the same thing, f1, it gives me 6. Okay, so in case of function, if you write this as capital or small, really doesn't matter. But there is one thing you need to know. That is, I cannot use n, e, then like n is for this. So I cannot use n as a variable. I cannot use e as a variable. So I cannot use capital I as a variable because those have different meanings. So there they will give you some error. This one is just a syntax. So as you can see that here, the only difference is, so somebody is asking if I put this one. So if you want to define this function, let me quickly check. So this is fine. it. Yeah, so this gives me an output of 5 plus x square. This will not give me an output if I put a dot. So that is the only difference, I think, but let me just check whether this gives me any value. Yeah. So if I put 2, it is 4 plus 6, it is 10. So this will not give me the output if I write like this, but if I write like this, it will give me back the function. Yeah, that is the only difference. So sometimes we didn't want the output, but sometimes we want the output. Another way of suppressing the output is if I put this one. So then the output will not come. So it is just, I mean, if you want, if you don't want, it's up to you. Okay. So I guess I'm done for today. Any more questions?
Any question?
Yeah, Niladri.
Hi, sir. I have a question.
Yeah, please.
Actually, my Mathematica is the version of 7.0. So that's actually when you plot the complex 3D or complex graph, then I cannot find the help.
Okay. So Anish, what you do is you share my link to all the participants. Hello.
sir.
No, I'm talking to the organizer. So I have already sent a link to the organizer. So
Okay, sir.
I think, sir, he's not there right now. I'll convey your message to him, and we shall certainly forward the link to the participants.
Yeah. So before 28, you forward them. So in my Google Drive, you will find Mathematica 12. There is a manual of Mathematica also, a book, and there is a book on mathematical modeling. So you download all of them and just install them in your laptop. Any more questions?
Any question, audience? Okay. So I conclude the session. Good evening, everyone, to the one and all present here, and speaker Professor Sandeep Banerjee, and all the participants. It is such an honor for me to get the opportunity to thank you all. On behalf of Department of Mathematics, ARSD College, I would like to express my gratitude to all the participants for their presence and contribution to make this course a great success. I extend my gratitude to our esteemed speaker, Professor Sandeep Banerjee, Department of Mathematics, IIT Roorkee, to take out his valuable time to enlighten us and to teach us about Mathematica. He teaches simple and basic arithmetic operators in Mathematica, which we can use in trigonometric and inverse functions by using Mathematica. We can also plot the function. We can use the palettes to write the mathematical expression in more readable manner. We can plot the graph in more colorful way. We can join the graph, we can manipulate the graphs, we can plot the graph in 3D, contour plot, parametric plot, and we can also use Mathematica for the list plot. And he also told us about the matrices, its inverse and properties related to the matrices, how we can find out the eigenvalue, eigenvector, characteristic equation, characteristic polynomial, and how we can find out the derivative of a function, how we can find out the limit of a function, plotting of the complex number, and how we can integrate by using trapezoidal rule and numerical methods like interpolation, and how we can find out the roots of the equation. Thank you, sir, for sharing your inspiring and wonderful experience in Mathematica. I also extend my gratitude to Mr. Rajkumar, HOD of our Department of Mathematics, to organize this course even amidst pandemic. I must thank the organizing and technical team who are really working hard to make this course successful. I am thankful to all participants for active participation. Thank you everyone.
Okay, bye.
Bye. So you can end the session.
Okay, sir.